Okay, so series test, next test, comparison test. This like statement, only statement. Let xn positive, yn positive for all the natural number, then there exists m also natural number such that xn is less than k times yn. K some constant, k positive number, and this your n must be your greater than this m. Select m. Then okay, so this right side series yn is converges. Then left side series summation xn is converges. Okay, so for converges, right side series converges, then left side series converges. But for diverges, okay, summation xn is diverges by any test, previous test, then summation yn is diverges. Okay, remember, if less than, then so summation yn right side series is converges, then left side series will be converges, and for diverges reverse. So summation xn is diverges, then right side series will be diverges. Okay, so see less than and greater than difference. Only statement. Proof will never ask. Okay, problems. See examples now here. Test the convergence of the series. So many series. Okay, you take away one by one. First series for summation xn series, and where xn is. So xn will be here 1 upon n square plus 2. B xn will be n upon 2n cube minus 1. C xn will be 1 upon 5n minus 4. And D xn will be 1 upon 4 raised to power n plus 1. So 4 problems. Okay, so first A part. So xn is this like 1n square plus 2. So we have n square plus 2 always greater than n square. I want less than some term. Yes, comparison test. 1 upon n square plus 2 will be less than 1 upon n square. Okay. Then, okay. So we have this right side series summation yn is the right side series. Okay, n square series p equal to 2. Just we have previous series p series test n raised to power p. Okay, then for p 2 greater than 1, then what you know, converges. Summation yn series will be converges. Now yn this right side less than this, therefore left side series also converges. Summation xn is converges. Xn term in the series summation where term is xn. Okay. Second so Yoxian term as a n upon 2n cube minus 1. Okay, so 2n cube will be greater than n cube. 2n square minus 1 also greater than n cube. Okay, therefore n upon 2n cube. Cube minus 1 will be greater than n upon n cube. That is 1 upon n square again. Okay. Now let right side summation of yn series as a 1 upon n square series. Now here p equal to 2, n raised to power p equal to 2, and that 2 is greater than 1, p greater than 1 converges. So summation of yn is okay converges. Okay, therefore left side series is converges. Comparison test, just we are studying here. Okay, comparison test, compare term, left side term with the right side term, compare. So comparison. Next, C part. Xn is a 1 upon 5n minus 4 now. So we have about the 5 minus 1. So 5n minus 4 will be okay less than 5n. Okay, now less than. Therefore 1 upon 5n minus 4 will be greater than 1 upon 5n. Or side change. Summation of 1 upon 5n will be greater than summation 1 upon 5n minus 4. Okay. Now this 1 upon 5n, 1 upon 5 outside 1 by n. So we have okay series 1 upon n. Okay, that is 1, 1 by 2, 1 by 3 harmonic series is diverges. Also p series test, p equal to 1. Okay. 1 raised to power 1, 2 raised to power 1, 2, 3 raised to power n. Okay, n equal to 1, so p equals to 1. So p equal to 1, then by p series test is diverges. P equals to 1. Okay, so left side diverges, therefore right side diverges. Therefore summation 1 upon 5n minus 4, this series will be diverges. So diverges, remember, diverges means left side, diverges, right side diverges. And converges, right side diverges series, left side will be diverges. So what is difference? Last. So Xn is 1 upon 4n, 4 is to power n plus 1. So we have in general 4 is to power n plus 1 will be greater than 4 is to power n. Yes, always for every natural number true. Reciprocal I want. So 1 upon 4 is to power n will be less than 1 upon 4 is to power n. Okay, and their series. So 4 is to power n. Okay, n equal to 1, 1 by 4, n equal to 2, 4 square, n equal to 3, 4 cube. This like what you know? Geometrical series. Okay, is a geometrical series. And what is common ratio? There, common ratio. R. Common ratio means this upon this, previous ratios. Okay, 1 by 4, 1 by 4 square by 1 by 4, 1 by 4. So common ratio less than 1. I think by geometrical series test. Okay, by the geometrical series test. Geometrical series test. Okay, ratio less than 1 converges, greater than 1 diverges. So therefore this series is okay, converges. Right side series converges. Therefore, given series converges. Okay, so this core problem. So comparison test and their problems. Another test. Limit comparison test. Just we compare this only series. Now limit compare. Limit of right side or ratio. This like statement. Xn positive, Yn positive for all the natural number. This such that limit of Xn upon Yn ratio. Limit of Xn upon Yn must be L not equal to 0 and not equal to infinity. So this L finite, then converges. Limit on depend on the limits. Limit exists means finite. So limit exists, converges, and this infinity diverges. Does not exist limit. Okay. So limit will be ratio, limit of Xn known to us. Finite to choose. Like this, compare less than, not here less than. This is a ratio I want. Another series Yn, here less than. Here also have to compare here. Not less than from near series, compare. And select what is a Yn, then their ratio. So limit exists, this C. Examples of this test is the converges of the series or diverges. So this problem 1 by 1 into 2, 2 into 3, 3 into 4 and so on. Second solution 1 by n square plus 1, n square plus 2. Three 2 upon 1 raised to power p, 3 upon 2 raised to power p, 4 upon 3 raised to power p. Okay, so this three problems. So limit check, limit of ratio Xn and Yn. Xn will be known to us and Yn have to choose near. Okay, so A part summation Xn as a 1 upon 1 then 2, 2 then 3, 3 then 4 and so on. So what is Xn now? Okay, Xn, n term will be 1 then 2, 2 then 3, 1 plus n, n then n plus 1. Okay, n then n plus 1. So n then n plus 1. This is same as 1 by n square plus n, n square plus n. So n square plus n will be nearly equals to 1 by n square. So I want nearly equals to select that yn. Okay, next series. So that is a nearly equals to, close to that series. Okay, xn. So this suppose a yn choice. Okay, let yn as a this 1 upon n square. Okay, so nearby series, select this one. Now ratio I want a ratio xn upon yn. Also limit test. So xn 1 upon n square plus n and 1 upon n square. So this comes to numerator, means n square and n square plus n. Separate this upon this 1 and this away n. So apply n is 1 plus infinity. Okay, does not exist. Limit does not exist. Means what? Diverges. Series diverges. Limit exists, converges. Stay here. So n square common. So this upon this we can take. In the numerator we can take. So n square common 1 plus 1 by n. N square common taken. So 1 by n. Now apply limits n tends to infinity. 1 plus 1 by infinity 0 1. So finite. Okay. Therefore given series converges. Not diverges. So you can tell this upon this and this upon this. Okay. So numerator can you can cross. So this and this. Okay, so converges. So this, so nearby series select yn. Choose like this. Second, I think 2 upon 1 raised to power p, 3 upon 2 raised to power p, 4 upon 3 raised to power p, and so on. So xn will be okay n upon n raised to power p, and then n plus 1, and then n plus 1. So this is nearby. Is upon this n by n raised to power p, that means 1 by n raised to power p minus 1 plus 1 nearby. So n upon n raised to power p, that is 1 upon p raised to power n, and that is your yn. So nearby series select. So therefore now ratio n tends to infinity, xn upon yn will be xn n plus 1 upon n raised to power p divided by yn Okay, 1 upon n raised to power p minus 1. Simplify. So this comes to numerator n plus 1 divided by n raised to power p into p raised to n raised to power p minus 1. This solve n raised to power p, n plus 1 same. So n raised to power p minus 1 and n raised to power p. N raised to power p will be cancelled. That means n raised to power minus 1 means 1 upon n. Now this we can separate. So here's problem. So this then we can separate. This upon this, n upon n, and this upon this. Now we can here separate. Denominator then not. So 1 by infinity 0 1 means again finite limit exists. Finite limit exists of this one. Therefore, by test, okay, given series will be converges. Okay, so for example, next, third, last. Okay, summation 1 upon n square plus 2. So clearly we have n square plus 2 will be nearly equals to 1 upon n square. So let yn as it 1 upon n square. Series 1 upon n square, n equal to 2, p equal to 2, greater than 1. Okay, so by sorry, not this one. I want converges, I want the ratio. I want the ratios. This test is ratio test. Limit everything. So limit n tends to infinity of xn upon yn. So xn original 1 upon n square plus 2, and this is 1 upon n square. So this comes to numerator n square and n square plus 2. Now same technique, highest power common here n square. I take n square will be common from denominator. So this cancel. And now upper limits 1 upon 1 plus n tends to infinity. This upon infinity 0. 1 by infinity 0. So one limit yes exists. Therefore series is convergent. So limit exists, convergent does not exist, divergence